Dear students, welcome to a new video for the Pure Mathematics course. Now we will begin the chapter 8, which is the differentiation. The derivative of a function of real number measures the sensitivity to change of the quantity of a function value or the dependent variable, which is determined by the other quantity or the independent variable. As we know that the standard form over linear equations or linear function that y equal to mx plus p, where y is the dependent variable. Dependent variables means that we depend on the values for x. Any value of x changes the value of y. So x is the independent variable, and y is the dependent variable. Now we measure how sensitive these changes occur. If we get a very big values for x, it changes the values of y, or if the values of x is a negative values or small values, if it changes the value of y, of course yes. But how sensitive these changes occur? So we use the differentiation rules to measure the sensitivity of changing the quantity, which is determined by the other quantity. Now let's imagine the derivative as here in the chart. The tangent line at a point here, L1, it is the slope of a curve for P. We have a curve here, and its slope here is at the point P, and we have a tangent line with this curve, which is L1. Now we will move to the rule for the differentiation. The rules for differentiation, we have the basic rules that we will study very well and calculate these rules to be very more qualified for the rules for multiplication and power rules and the chain rule. We concentrate on these basic rules for the differentiation because these are the basics for all any differentiation rules, including the division rules, the multiplication rules, the chain rule, the power rule. Just the basics is very important. So if we have d over dx, which means the derivative of any value which is constant as c, the result will equal to 0. If we have x to the power n function and we want to get the derivative for it, which is d over dx, this means the derivative of it, here the derivative will be multiplying the power of this value by the value and make the power -1. So will be the derivative for d over dx will be x n x to the power n minus 1. And if we have a constant factor rule and constant multiplied by a function, say f of x, so the constant will be taken out as a common factor, and then we will multiplying the constant by the derivative of the function simply by using the rule number 1. So we will take more exercises in these basic rules because this is the more important part in the differentiation to be qualified enough in this point and get more the other any other rules is more easier. In A, if we have f of x as this function is equal to 2x to the power 3 over 5, we get the value of 2 over 5 as a constant here, and take f of x equal get the derivative for it. Note that the differentiation for f of x can be written as f dash of x, which is means the derivative of this function, or maybe d over dx. Also, this means the derivative of this function. Or if the function in the form y equal to 3x, for or d over dx or d or y dash or dy over dx. This all means that we want to get the derivative of the function given. Here, the function is equal to 2 over times x to the power 3 over 5. So we will get 2 over 5 multiplied by the function. The derivative of this function will be here 3 will be multiplied by 2. 3 times 2 equal to 6 times x squared, which is 3 minus 1 over 5. So this is the result of this function. Another example, we have P that f of x equal to 4 over 7 times x to the power 3. This means that 4 over 7 equal to x to the power negative 3 by using the power rules. So we will simplify first the derivative as possible and then get the derivative here, or simplify the function as possible and then get the derivative. Let 4 over 7 out of the function and get the derivative of x to the power negative 3 equal to here negative 3 times x to the power negative 3 negative 1, which is equal to negative 3 times x to the power negative 4. Also, we get it in more simplified form where the power in the denominator is by a positive value, so it's equal to negative 12 over 7 x to the power 4. Let's move to another example for the differentiation, which is f of x equal to 5x squared minus 3x over 4x. Here, note that we will simplify the function given as possible to be more simple when we make the differentiation. So we can take x as a common factor from the numerator and the denominator. So here will be x as a common factor, 5x minus 3 over 4x, and then eliminate the x from numerator with the x with the denominator. So the value of the function will be, after simplifying, will be 1 over 4 times 5x minus 3. Note that till this point we don't make the differentiation, just we simplify the function to be more simple when we differentiate it. Then we will simply get the definition, the derivative for this function by 1 over 4 is a constant out of the calculations and times the differentiation of the function, which is 5 when times 5x, the derivative equal to 5. So the total value is equal to 5 over 4. Another example for differentiating sums and the differentiating of functions. So if we have f of x equal to 3x or to the power 5 plus root x, which is equal to 3x to the power 5 plus x to the power half. As the examples in the previous slides, with that we already get the basic rules and use basic rules to get the differentiation. Here equal to 3 times 5 to equal to 15, and 5 minus 1 equal to 4. So the derivative of this is equal to 15 x to the power 4, plus sign here, and x to the power negative 1 here, multiplying negative 1 by x, so it will be 1 over 2 x to the power half minus 1, which is equal to negative 1 half. So equal to 1 over 2 root zx. This is the final result of this differentiation. Let's move to another one, which is p. Here, z to the power 4 over 4 minus 5 to the power 5 over z to the power 1/3. So here 1 over 4 is the constant out of the differentiation, and multiplying by the derivative for this value, which is 4 here, 4 times and 4 times z or to the power 3. This is for the first part. And the second part, which was equal to 5 times z over 1/3, negative 1/3, will equal to 5 times 1 over 1/3 by negative sign over times z to the power negative 1/3 negative 1, which is equal to negative 4 or to the power 3. Here, by simplifying it all, we get z to the power 3 plus 5 to the power 3, 5 over 3, z to the power negative 4 over 3. And we can get it by here a positive exponent like this, z to the power 3 plus 5 over 3 z to the power 4 over 3, or roots, a third roots for z to the power 4 also. Check your answer in a simplified form. Now we will move to a very important topic in the derivative, that join the tangent line or the function in the standard form y equal to mx plus p by getting the derivative, which at this point is the finding an equation of a tangent line. As mentioned in the previous slides, that we have a tangent line and have a curve, and we have what is meant by a tangent line, that is line here for this curve, and we have in this line, on this line, a point which is the slope of the line is equal to m. If we ask about the equation of a tangent line, we want to get the standard form equation that have the unknown variables x, y, and m. So we will join the rule for the standard form function that we have already got in chapter 2 by using the derivative concepts like this. First of all, if you have a function y equal to 3x squared minus 2 over x, when x equals 1, we can get the value of y by substituting x. So here y will equal to 1. Great. Now, if we want to get the standard form, we can apply the rule that we already covered in chapter 2, which is y minus y1 equal to m times x minus x1. According to the given in this example, we already have the values for x1, which is x equal 1, and the value of y1 by substituting in the function given, and y equal 1 also, and we have another unknown, which is m. We can get the value of this unknown by substituting by x1 in the first derivative of this function. So we get the derivative, first derivative for this function by here 3x squared minus 2 over x, which means 3x squared over x, which is 3 over x, minus 2 over x. So the first derivative will be 3 plus 2x to the power negative 2. At x equal 1, the first derivative will equal to 5. So we already here have the values for y1, which is equal to 1, and the value of m, which is get it from the first derivative by substituting in x equal 1 equal to 5, and x here unknown, and we get the value of x1, which is given here, equal to 1. Now simplifying this function to get y equal to 5x minus 4 and this is the equation of the tangent line to this curve. So take care when we asked about the tangent line, you should get the values of x1, y1, and the value of the slope from the first derivative of the function. We will move to another topic, which is the products or the multiplication of two polynomials function and also the derivative for the division. First is the product rule for the differentiation, which is the derivative for the first function times the second function without differentiation plus the first function without differentiation times the derivative of the second function. For example, if we have f of x equal to x squared plus 3x times 4x plus 5, the derivative of this function will be the first function differentiation equal to 2x plus 3 multiplied by the second function without differentiation 4x plus 5 plus for the rule sign and plus here the first function without any differentiation x squared plus 3x times the derivative of the second function, which is 4. Okay, another rule, which is the division rule. The division rule or the quotient rule that take care that we have a negative sign, so take care very much from the order of your multiplications and the order of the two functions equal to the denominator without any differentiation, the denominator value or the denominator here function without differentiation times the differentiation of the numerator minus the value or the polynomial of the numerator times the differentiation for the denominator over the denominator square. Let's apply this rule more simply by using an example. If you have f of x equal to 4x squared plus 3 over 2x minus 1. Let's get the value of f dash of x equal to the first we will begin. Remember the key of saving this rule is that we began with the denominator without any differentiation. So we get the value of the denominator, which is 2x minus 1 times the differentiation of the numerator, which is equal to 8x minus the numerator without any differentiation times the differentiation for the denominator, which is equal to 2 over the denominator square. Here is the value of our differentiation. Now we will take more examples for the differentiation function that we take for it before. Higher order derivatives. Higher order derivatives means that we have the same function, but we get the derivative for it again and again up to the numbers that we want to get the derivative, or up to get the function equal to 0. This means without any variables. So the first derivative, which is denoted by y dash, may be denoted by f dash of x or y over dy over dx or d of dx for f of x or dxy. All these different denotations for the first derivative. Also, the second derivative can be denoted as these forms. All this row, the forms for the notations for the second derivative. Y double dash, f dash double dash x, d square, y over dx square. Please take care of this form. It's not mean that we squaring the rule. We just mention for the second derivative for the function. Also, the third derivative may get in this form y triple dash or f triple dash x or d to the power 3, not mean that we have d to the power 3 over dx, absolutely, or only get the third derivative of the function, or d squared to the power, sorry, d to the power 3 over d x to the power 3 for f of x, or in this form. Note this format because the question may get one of the forms. So if you want to get the higher derivative or higher order derivative for any function like this, we differentiate it for more times until we get the derivative equal to 0. So f of x equal to 6x to the power 3 minus 12x to the power 2 plus 6x minus 2. The first derivative is 18x squared minus 24x plus 6. The second derivative equal to 36x minus 24. Third derivative equal to 36. And finally, the fourth derivative equal to 0. Okay? So, the solutions. Another example where f of x equal to 7, it's a constant function. So from the first derivative, it's equal to 0. The second derivative also equal to 0, and so on. How to evaluating the second order derivatives? We may get a value or another function, and we want to get d squared y over dx squared. You know from the table in the previous slide that this means the second derivative. So getting the first derivative first, if we put this function in the form 16 times x plus 4 to the power negative 1. To simplify, to get rid of using the functions or the rules for addition, division. So we can get in this form 15 times x plus 4 over to the power negative 1. Getting the first derivative equal to negative 16 x to the x plus 4 to the power negative 2, and then the second derivative equal to 32 x plus 4 to the power negative 3. Here, the question wants the value of the second derivative when x equal to 4. So, substituting the value of x with 4, we get the value is the second derivative when x equal to 4 equal to 1 over 16. The test or the second derivative test. It's a very important test used to test the certain critical values for relative extremes. If we have a quadratic curve like this, and we want to know the extremes for the curve, where it is the relative minimum point and what is the maximum relative point. So we are applying the second derivative test as follows. Applying or supposing that the first derivative is equal to 0, then we have three cases. The first case, that's the second derivative of a less than 0, so f have a relative maximum at the point a. And if the second derivative of a greater than 0, then f has a relative minimum at a. And finally, if the second derivative of a is equal to 0, then the test fails. Let's move to example to be more practice in the second derivative test. The question is, test the following for the relative maxima and the minima. Use the second derivative test as possible. If you have the function that y equal to 18x minus 2 over 3x to the power 3. First, we will get the value of the first derivative. So, y equal to 18x, the first derivative equal to 18 minus 2 to the power 3x squared, here 3 times 2 to the power 3 multiplied by x to the power 3 minus 1, which is equal to 3 to the power 2, x to the power 2. So y dash equal to 18 minus 2x to the power 2. Now we can take 2 as a common factor, 2p, 2 times 9 minus x squared. This is the same value because we just take a common factor and get 9 minus x squared equal to 3 plus x times 3 minus x. Then we can get this for the first derivative. Second derivative is equal to, here, the second derivative is equal to 2 times 9 equal to 0, the derivative of the constant, minus 2x, which is equal to 0 minus 2x equal minus 2x times 2 minus 2 minus 4x. This is the second derivative. Note that we have here the first derivative equal to, here, 2 times 9 minus x squared, and the second derivative equal to negative 4x. Now, applying the second derivative test. If we convert the first derivative as a zero function and get y dash when equal to 0, here we can solve the equation, zero equations that may be x equal to positive 3 or negative 3. And substituting with the two numbers in the second derivative test here. Okay, so if we x equal to 3, y double dash will equal to 3 times x negative 4 equal to negative 12, and negative 12 less than 0. So we have a relative maximum at x equal to 3. And when x equal to negative 3, the y double dash equal to negative 4 times negative 3, which is have a positive value, which is greater than 0, have a positive value, and the relative minimum at x equal to negative 3. Now we can determine from the second derivative test what is the maximum point and the minimum point. Another example, if you have y equal to 6x to the power 4 minus 8x to the power 3 plus 1. Use the second derivative test to determine the relative maximum and relative minimum if it exists. Again, we will get the first derivative like this and get the values for x. So we have for 24 x to the power 3 times 3 to the power 3 and 24x to the power 2. Get a common factor. So we have two values for x, which is 0 and 1. Then get the second derivative, which is 72x squared minus 48x, and substituting with the two values 0 and 1 in the second derivative test. When x equal to 0, y double dash equal to 0. And this means that the test fails at this point. And we can't apply the test when x equal to 0 because y double dash is equal to 0, 0. And when x equal to 1, y double dash equal to 24, and 24 greater than 0. So the point is that we have a relative minimum when x equal to 1. So we can determine the minimum point, and at the other point the test can be applied. Another point in the differentiation rule, which is the chain rule. Chain rule is a very important rule when we have two different functions and with 3 different variables. I mean, we have y, it's a function of u, and here u is a function of x. And we want to get the derivative dy over dx. So we first get the differentiation for the first function with the basic rule for the derivatives, and the differentiation for the second function with the basic rule of simply with the basic rule for derivatives, and then multiplying the results with each other. Here, as in this example, note that if you have y equal to 2u to the power 3 minus 3u minus 2, here y is a function of u, and you have another one which u equal to x squared plus 4. I mean that u is a function of x. Here, let's note that we want first to get dy over du to be here 4u minus 3, and then get du over dx here 2, which is 2x, and applying the chain rule that dy over dx equal to dy over du times du over dx. Here, multiplying the two derivatives together, we get 4u minus 3 times 2x. But note that here is u and x, and we want the derivative dy over dx. We should get all as a function of x. So we substitute the value of u that is given in the example by x squared plus 4. I mean, every u is substituted by x squared plus 4. So 4 times x squared plus 4 minus 3 times 2 is x3, so our product will equal to 8x to the power 3 plus 26x. Another example for the chain rule, y equal to root w, which is equal to w to the power half, and w equal to 7 minus t to the power 3. Find dy over dt. Note again that we have 3 variables dw and t, and we want the function or the derivative dy over dt. Now, getting this value, first differentiate the w over to the power half equal to half w, okay, to the power -1, and getting the value 7 minus t to the power 3, which is equal to -3t squared. Multiplying each other, we get the value -3t squared over 2 root w. But we want dy over dt, not w. So we substitute every w with 7 minus t squared to be this result. Let's move to the power rule for the differentiation. The power rule is very simple. If we have, for example, let's make another example very simple, x to the power 4 plus 2x to the power 3 all to the power 5. Now, how to use the power rule? Here, we will differentiate it by 5, like the basic rule, times all what inside the rule without any differentiation or without any change, for x to the power 4 plus 2x to the power 3, times the derivative of the inside rule, which is 4x plus 2 times 6x squared. This is the power rule for the differentiation. We use the 5 to the power times x to the power 4 plus 2 to the power 3 all to the power 4, which is 5 minus 1, times the differentiation what is inside the brackets. Here is another example, but more gaining more steps, which are a root with a radical sign, and for the third root, this polynomial all to the power 2. First, change the to the power 2 equal to 4x squared plus 3x minus 2 all to the power 2 over 3. And getting that 2 to the power 3, the same, not to change anything, 2 to the power 3 minus 1, then differentiating in what is inside the rule, 2p 8x plus 3. And the final form for our calculations is this form. We can ask what is the derivative for this function when x equal to negative 2. Here you will substitute each value for x by negative 2 and calculate it simply. Another example for using the power rule for in the differentiation, like this. If you have y equal to 1 over x squared minus 2, you can convert it to y equal to x squared minus 2 all to the power negative 1, and use the power rule as follows. Negative 1 x squared minus 2 without any differentiation, 1 minus negative 1 minus 1, which is negative 2, and differentiate what inside the brackets. So we'll get 2x. The differentiation for x squared minus 2 is 2x. So the final result will be negative 2x over x squared minus 2 all to the power 2. And this all for the differentiation rule. Thank you for listening, and we continue our lectures again.